VW and Audi vehicles are prone to fuel trim concerns. VCDS can be used to monitor fuel trim values in real time. If you're unsure about what fuel trim is, we recommend you watch the following videos to have a good base understanding of fuel trim. The first video covers the basic concept of fuel trim. The second video is from a training class that goes into great detail about fuel trim. Just click on them to view the content. Long-term fuel trim is found in measuring value block group 032. Short-term fuel trim is found in measuring value block group 033. In this first example, the values are being shown for an inline 4-cylinder single bank engine. With VW and Audi vehicles, there are two values for the long-term fuel trim, idle and partial. Idle is the value in the first field, and as the name implies, it is the long-term fuel trim for the engine at idle. The second field has the partial value. This is the long-term fuel trim value for when the engine is under load. In measuring value block group 033, field 1, the short-term fuel trim value is displayed. On V and VR engines with two banks, in measuring value block group 032, field 3 shows bank 2 long-term fuel trim at idle, and field 4 shows bank 2 long-term fuel trim partial. In measuring value block group 033, field 3 shows the short-term fuel trim value for bank 2. Long-term fuel trim values are the corrective actions of the engine control module based on the short-term fuel trim. This is a 2012 Golf R. The long-term fuel trim at idle is 1.5, a good reading, and the short-term fuel trim is switching between rich and lean. Now let's induce a vacuum leak. With this type of engine, the crankcase has a minor vacuum at idle, so pulling the dipstick up creates an intake leak. The short-term fuel trim jumps up to show a lean issue, unmetered air. The dipstick is inserted but not fully seated to allow unmetered air to continue to enter the combustion chamber. With this vehicle, it took about 90 seconds for the long-term fuel trim to increase. As this happens, the short-term fuel trim decreases. At face value, these readings look good. Long-term fuel trim at idle is 3.6%, and the short-term fuel trim is switching between rich and lean. But with the dipstick not seated, given enough time, this will flag a fault code for fuel trim. When you send the clear codes command, the long-term fuel trim values are cleared out and set back to 0%. So with the dipstick still not fitted correctly and allowing for unmetered air, let's clear codes and then jump back into measuring value blocks group 032 and 033. Done, go back. Fault codes, clear codes, confirm yes, done, go back, measuring blocks, group 032 and 033. With the leak still present, after sending the clear codes command, you can see the initial readings of the short-term fuel trim has returned to a very high reading, greater than 10%. The long-term fuel trim has already started to make corrections. After about 60 seconds, the readings have stabilized. In a moment, the dipstick will be fully seated, thus fixing the false air issue. With the long-term fuel trim value correcting the short-term fuel trim readings based on the false air issue, once the dipstick is seated, the long-term fuel trim correction will cause the short-term fuel trim to go rich. Now that the false air issue has been resolved by fully seating the dipstick, let's clear codes, then jump back into measuring value blocks group 032 and 033. Done, go back. Fault codes, clear codes, confirm yes, done, go back, measuring blocks, group 032 and 033. With no false air issues, the initial short-term fuel trim does not go above 10%, a good reading for having just reset the long-term fuel trim values. Again, you can see as the long-term fuel trim for idle goes up to correct for a mild lean issue, the short-term fuel trim values go down. After 3 minutes, the long-term fuel trim at idle has returned to the same value prior to inducing the intake leak, 1.5%, and the short-term fuel trim is switching between rich and lean again. The long-term fuel trim partial value in field 2 is still at 0% since the clear codes command was issued. Until the car is taken for a test drive, it will most likely remain at this value. A method to help find intake leaks is to use a flammable source such as propane gas or carburetor cleaner. In this example, carburetor cleaner is sprayed into an area where suspected cracked hose is causing an intake leak. Hydrocarbons from the spray are sucked into the engine and cause a short-term fuel trim to go rich, confirming an intake leak. The cracked hose is repaired, and when the same test is repeated, the short-term fuel trim does not jump to a rich reading as before. As noted at the beginning, VW and Audi vehicles are prone to fuel trim concerns, most of them being false air issues as shown in this video. Other problems not covered in this video can cause fuel trim concerns as well, such as fuel injectors, fuel pressure, spark plugs, mass airflow meter sensor, and O2 sensors. The goal of this video is to give you a starting point in using fuel trim to help diagnose and repair vehicles.